Welcome to our Introduction to Operations, part of our series of Hadoop architecture overviews for you, our partners. My name is Sean Roberts. I'm a partner engineer based in London, supporting primarily our partners in EMEA, but working with many of you across the globe. In this introduction, we'll spend 1 to 2 hours talking through Hadoop operations. This is intended to give you an overview of what you need to think about throughout working with Hadoop and talking through your customers, whether in pre-sales or once their clusters are deployed. This material is based off of a collection of workshops and other training courses, which I'll mention throughout this video. And you should ask us afterward if you want to go into more depth, such as full-day workshops for your pre-sales and solutions architecture teams, or if you're interested in the longer training for your professional services and other teams that are operating and deploying clusters. You can do so by visiting us at Partner Desk or emailing us at partnerdesk@hortonworks.com and visiting the many partner pages throughout hortonworks.com. Now, of course, I always start with a disclaimer, and it's largely because we work in an open community. So I can't set firm dates, and any future features I mention could be potentially changed depending on how the community wants to work with them. That's a benefit and just part of working with the community. Now, you've seen this slide before, and I'm not going to explain anything on it other than the fact that something you should acknowledge and you should definitely talk to your customers and colleagues about is what Hadoop means. Now, when we think Hadoop, we think of something very large, but Hadoop at its core, especially if you just look at the project, if you go to hadoop.apache.org, it is storage and compute. It is HDFS, Yarn, MapReduce, and a few shared libraries. But when we think Hadoop, we think of a large distribution of many packages. Just as if you think of Linux, you don't only think of the kernel, you think of the kernel, the libraries sit on top, and everything you install around the Linux to have a functional operating system. The same is true with the Hortonworks data platform. As you can see on the screen, this is what we offer as part of our distribution today, and as time goes by, as you've seen throughout our last few years, we continue to add projects. And further, there are partner projects and other open source projects that can be installed on top of the Hortonworks data platform to make it a more expansive system. Now, all that to say that often people will mention that operating Hadoop is hard. But I propose that it's not that much harder than operating other systems. For example, if you're deploying a large web stack, then you have a large collection of tools which you have to manage separately. First, you have the operating system you run along with its login rights, and separately its file system permissions and other security concerns, and general backup and operations, rotation of its logs, and so on. Well, then you need a web server. So maybe you use the Apache HTTP server. Then maybe you want a caching server, so you put that in place too, as Squid and Nginx or one of many other servers, maybe a proxy service in front of that. Then you need various databases, so you have some sort of SQL system, but maybe you want a NoSQL system all for a different aspect of the website. And then a caching database, or key value store, possibly also add a message queue. All of these are separate projects, all that you have to manage separately. Now, when we look at Hadoop, we often think of one thing. I want one thing to manage. But if you look at it as a whole, it's a collection of separate projects that happen to be running on top of Hadoop, HDFS, and Yarn, as some would call Yarn the data operating system. It's a good point to remind yourself of, especially when you're working with their customers when they say they want to operate Hadoop. Make sure they understand what they're saying. Now, when it comes to operations, we're starting at the very beginning. We're starting before we ever deploy a single bit of hardware, before we ever install anything. And so it's very important to plan, especially with Hadoop, because one thing that is a challenge with Hadoop is that we're making multiple servers, anywhere from 8 to 1,000 or 10,000 or more act as one computer. So you really do have to put more planning into it than you might put into other systems. You can use the analogy of Tetris with all your pieces stacking up, a few wrong moves, and it stacks up really fast. Now first I want to mention people, because this is overlooked. We often dive into the tech, and we don't talk about the people. And then after people, we'll talk about the process and the overall platform. First, you need to think about your roles and responsibilities. I'm not going to talk through this slide. It's a brief snapshot I took from one of our offerings that you can ask us about, again, at partnerdesk@hortonworks.com. Our professional services team offers something we call our COE incubator. And what it does is help you or your customers to become a Hadoop-enabled organization. These are just a few of the titles involved. Now, if we look at an organization, they often have these things on the left. A data architect, an analyst, possibly if they're doing more advanced things, they have developers, and they definitely have administrators in their organization. So we offer training courses that enable those people to become the equivalent Hadoop role, such as a cluster operator, a Hadoop analyst, a Hadoop developer, Hadoop architect, and so on. Sorry for the jumping around. You can find out more if you go to training.hortonworks.com, or again, if your organization wants to have some turnkey just for you, where you have a large number of people in your organization that want to participate in training, again, hit us at partnerdesk@hortonworks.com. Now this is you. The generalist, the do-it-all. I had to choose between Chuck or MacGyver in this situation, and I went with Chuck. So the lead persona in our roles that we'll work through today is the Hadoop operator. This person needs to be a generalist. They need to have skill sets across many areas, such as systems administration, database information, security administration, and network administration. But unless you're dealing with a very small environment, they can't do that alone. They'll still need the supporting personas throughout the organization. The people there you see on the right who will support them and be maintaining these separate systems and maintain the base systems that Hadoop runs on. Now, the goals of this administrator are, one, to scale operations. Remember, Hadoop is a large number of nodes acting as one. So provisioning new services, managing them, and monitoring them, and ensuring they scale is one of the key roles involved for this individual. And Hadoop clusters grow. When a project is successful, the clusters simply grow. And then more projects come and the clusters continue to grow. Next, they need to integrate the enterprise. This happens from day one. If you get a cluster up and running, you're likely going to want to integrate it with your directory system and your Kerberos for security. For example, with Active Directory. Further, Hadoop on its own isn't much use because you want to get data in and out of it, likely from existing systems. So the role of this individual is to guide others in the organization on how to integrate those with Hadoop. Then they need to extend the ecosystem. You may only start with a pilot that uses Hive for SQL on Hadoop. But then you look to use other parts of the platform and integrate them all. And then further, you may look at other partner solutions that sit on top of Hadoop, or even future projects as they come along, either into the Hortonworks data platform or just in general within the community. This is a community, as you know, that continually changes, and this person has to keep up with that. And finally, they need to coordinate services. Scheduling of jobs across the cluster, ensuring capacity, maintaining, backing up, all these things fall in the remit of the Hadoop operator and their team. Now this individual is now long. Once you get past your single pilot or proof of concept, the cluster will grow and you'll have many project teams or departments. And just as you would have in any organization, you'll have some delegation relating to Hadoop. So let's you have a project team or a department or a business unit. Within that, they will have many roles such as Hadoop developer, Hadoop analyst, Hadoop architect, but they'll also likely have a Hadoop operator. And it may be a shared role with other roles within that team, but this person will be delegated a few tasks from the Hadoop operator so they don't have to manage every little thing in the cluster. Examples of this are tuning Yarn specifically for that group. The primary Hadoop operator can delegate a section of Yarn to this individual in that project for them to manage. Other resource allocations, such as creating tables in Hive, specific folders, and then all the security relating to those resources. And finally, general troubleshooting for people in that team. They become the SME, as it were, for the Hadoop cluster to that team. And they can bring requirements back to the main Hadoop operator for future changes to the cluster or growth of the cluster. Now this is a little snippet showing a few of the questions and things that the various roles come to our support teams about. It's important to note that to be successful, you're really going to want to engage Hortonworks support from the early days. And finally, we ask that you join and build the community. We've recently launched community.hortonworks.com, where you can ask answers, where you can browse the knowledge base, you can share code, and much more. Further, we have the Hadoop Summit, both in Europe and the US. I believe we're launching them around the world in 2016. We also have meetups globally, which we hope that you can participate in, and even better yet, why don't you volunteer to host an event? Hosting such an event would bring their community into your organization, benefiting you with the knowledge that comes from being around those individuals, but also highlighting you as a leader in the Hadoop community. And finally, we've started kicking off hackathons such as the Ambari hackathon we had in 2015. That was a great success and added several new features to the platform. Again, that's at community.hortonworks.com for everything you see there on the right. Another note around community is inside your organization or your customer's organization who you're thought leading into Hadoop, you likely want to foster a community as well, such as an internal user group or internal mailing lists. Now let's get into the process and the platform of operations. The first thing that comes up is the architecture considerations. Some of this you've likely seen before, some will be minor updates. Now I'm going to say very high level, so remember, contact us after if you want more detail, and look forward to any future workshops we offer. Key considerations around architecture are the infrastructure, how you size for that, and then something we call the component layout. Now, the most common questions I get around infrastructure are where and how. Now, I'll separate the where and how. So on the where, we have the various cloud infrastructures. Now, nowadays, they could be virtual containers or bare metal, which is why I've separated them. And that cloud may be a public infrastructure as a service offering, or it might be a turnkey Hadoop as a service offering, most notably Microsoft's HD Insight and Rackspace's Cloud Big Data Service. When choosing this, it's truly a matter of your business choices, what works best for you. Some companies have an all-cloud practice. Some companies can start more easily on the cloud and then move to dedicated. And some companies take what's called a hybrid approach, where they have a vendor who has both cloud and co-located facilities in the same location, so they can mix that. And it may be private cloud or some sort of virtual infrastructure internally. Other options, and the most common, is an on-premise data center, a co-located data center where you put your servers in an existing data center and another organization manages the hardware for you. And after that, you have full managed hosting, where you have a host such as Rackspace, or for larger enterprises, HP, who offer very high-level services, often down to managing at the root level of those servers and doing everything for you, including backups. Again, choosing these options is really about how your business works, what works best for you. Now, next to that, we get the question about, what about the technology behind it? Should I use virtualization? Should I use containers? Should I use bare metal? Now, again, that is largely a choice of how your business works. Now, obviously, running pure bare metal is the most efficient. After that, containers are pretty close to the efficiency of bare metal. And then on top of that, you have virtual, which takes a little bit of efficiency hit, but if structured right, isn't that large. But the choice is really down to the organization and where they best fit. If your entire infrastructure is virtual, then adding a few bare metal systems could just be more overhead of training your people and different processes than sticking with virtual. But if you do go with virtual host, be careful not to model them like you would other servers. If underneath a virtual server you have RAID for your HDFS disks, then not only is HDFS replicating the data, but then the RAID underneath the virtual hypervisors is also replicating data, so you have a huge amount of waste there, huge amount of overhead. But in some cases, you might opt for virtual, even if you're using bare metal or cloud servers. Such a case may be for masters, where you could utilize better failover, better redundancy methods if a master fails. Then finally, we have questions around storage. Now, traditionally, we always look at local disk, local to the server. Whether it's virtual or bare metal, it's local on the same physical server. The reason being is Hadoop was built around locality of data where compute and storage are together. Now, some are recently moving into using SAN as a storage option. Whether they're on dedicated servers or they're on a cloud host where they're using a block storage, which acts much like SAN, this is an option, but you have to architect it for it very, very, very carefully. This is something I would say to reach out to us to understand better. If it's architected right, it can work. It's rarely quite as efficient as local disks, but it might be easier for you to scale, or you might be taking advantage of leftover SAN storage that you have laying around. Other options that come up are object storage. So this would be Microsoft's blob storage, Azure blob storage, Rackspace's cloud storage or OpenStack Swift, Amazon S3, or Google Cloud Storage. Now these are options, but they typically don't replace HDFS directly. Microsoft has engineered Azure for that replacement, but for the other offerings, we look at them more as a loading, ingest pattern, or for read-only access, or for pushing data out. Again, this is something I would consult with us about the best use of these technologies. And finally, people ask about Isilon, which is in its own category. It has been made to be a true HDFS-compatible file system. And if someone's already using Isilon today, then adding a dupe to that is a great way to get started. The customer already has all their data there. They likely are wanting it for POSIX compliant uses, likely wanting it for shared file stores and many other things. And it's quite easy to connect a Hadoop, a Hortonworks data platform cluster, which only has compute, to Isilon, assuming you build the network right. It's very common with our customers, and it typically happens that people already have Isilon in place, and they say, I want Hadoop, and it's a very easy thing to put in place there, compared to starting all new storage with Isilon and then adding Hadoop. So if anybody's using Isilon already, call them immediately and start talking about how they can add the Hortonworks data platform to that. Now these are a lot on these slides. We will be distributing these slides along with the video, so don't worry about reading this, and I'm not going to go through it all. It's just to give you an example of what's out there. But when we're looking at hardware, we're generally looking at general hardware. Some people call it commodity. I like to call it standard. But this is hardware that is not the leading edge, but not far behind. You want something that's going to be supportable for quite some time, but you really want to depend on the software for most of the redundancy. Now there are two general machine classes within a Hadoop cluster. You have your masters and your slaves. Now your masters are where you're going to want to invest more. They need to be designed for availability. These will be just like the masters that you've built in traditional database systems and other systems, where they're in an HA environment either of 2 servers or 3. They're enterprise grade, they have multiple network cards, they have multiple power supplies, they have RAID under their primary disks, and so on. And you're going to want a strong vendor SLA just as you would have for any other masters in other parts of your organization. Now, with slaves, we're designed for affordability at scale. We want that best price point per either storage amount per gigabyte or terabyte or per compute, depending on what you're doing with those nodes. They want to be commodity or standard class servers, nothing special about them. The resiliency comes from the software. Now, if you're dealing with a very small cluster of, 16 nodes, then you might want to have You might want to have a little resilience in those nodes. But once you get beyond that, you don't need a lot of resiliency. Because if one fails, then it doesn't matter that much once you get to a significant number of nodes, because HDFS handles that for you. Further, to reduce your other costs when you're talking to your customer, you can reduce your SLAs that you offer on those nodes. You're selling the same hardware, you're offering the same services, but the response time is a little bit slower next business day, or even longer if you have a very large cluster, and that allows you to pass some savings on to your customer, and reduces your burden of having to run out every time a data node fails, or a disk fails. And finally, we have the networking layer, which typically now is 10 gig. There are even people now looking at 100 gig networks where they're looking to super compensate at the network, especially if they're looking to separate the storage and the compute. There's many options for also how you connect the switches, which we can cover in a deeper session if you talk to us. Now, this is something you've seen before, but I want to give you a little update. So typical hardware we're seeing nowadays for our nodes is actually up to 256 gig of RAM. Now, that's not when you're just starting out in a pilot and you're running you on use case. We see this from customers that have been using Hadoop for some time, and they're using most of the ecosystem. So they're using Hive, they're using HBase, they're using Spark, they're using many of the projects, and they are running lots of jobs on the cluster. And as you know, if you're running jobs, every job uses a Yarn container, which needs RAM and CPU cores allocated to it. If you're running a pilot, then you may be able to start with less to prove that out before you further build the production cluster, especially if you're only going to be running a few jobs in that environment, or one or two projects such as just Hive and HDFS. Now, for the primary disks, typically we see people have 2 terabyte disks, whatever the best price point is with your vendor, and they're RAID 1. Even on the worker nodes, you would do RAID 1, unless you're getting to a very large, over 100 nodes. Because if just one disk fails, then you lose that entire node. And let's say you have 20 terabytes of HDFS per node. That's 20 terabytes that has to be re-replicated across the cluster. So that RAID 1 on the OS, even in workers, helps to save from a big hit to your cluster. Now for the disks, you'll see that for the masters, we've got anywhere from 8 to 12, 1 to 2 terabyte nodes. The 1 to 2 terabyte down to 1 potentially gives better performance. It depends what that master is doing, what services is running. Typically, we see the masters having dual 10 gig network and the workers having single 10 gig network, unless you want to up that to dual. Though, as I mentioned, some people are even going with 100 gigabit networks now, and in some really future-looking or SAN-based architectures. And I forgot to mention the worker disks. It's almost always 8 to 12 is what we recommend for being maxed out. You don't want to go much beyond that. Typically, you want to have a good ratio of the number of cores a system has to the number of disks it has. And nowadays, they're anywhere from 2 to 6 terabyte, all depending on the use case. Or if it's a general use case, it's typically 2 to 4. But again, it's going to depend on the vendor and their price point and the performance you're expecting to get from the cluster. One little tip, though, is to check with your vendor about how their RAID controllers work. Almost all servers are going to have a RAID controller, and when you connect individual disks and you want them to act separately, there's 2 options. There's just a bunch of disks, called JBOD, or there's RAID 0 per disk or per spindle. Now, they might look like the same thing, but they actually behave differently. In most controllers, the RAID 0 per disks performs slightly better than JBOD because of caching, but not in all cases. And one little note, people ask, why the big jump from 128 to 256? Why can't I just go to 196? Why is not that the standard? Well, I won't go into depth now. If you go to community.hortonworks.com and search there, you should be able to find it. If not, ask. It has something to do with at least the current Intel CPUs and how the CPUs map out to RAM and the number of slots of RAM you have. If you go with 192, then you are falling somewhere in the middle and you're not properly and fully using the CPU. So I'll just say go with 128 or 256, or read up on that and see if it's worth going with somewhere in the middle. This is further showing what the rack looks like. Again, I'm not going to go through all the detail of this, but you're typically going to have a top of rack switch or another structure, and then you'll have your master nodes and all your other nodes in there. As you scale out to multiple racks, you'll look to distribute those master and gateway nodes across the racks, therefore distributing any risk across multiple racks. Now let's briefly get into sizing. So in sizing, the first thing you're going to do before you even just start working with a customer is you're going to look at the size of storage. Now I'm not going to go through the math here. Again, you have these slides to work with, but it's not quite as simple as just dividing by 3 as some people do. There are overheads that you need to calculate for within Hadoop. So take these calculations. You can find similar ones throughout our website, throughout community.hortonmarks.com, and throughout the internet. Use this to determine next what your worker node count looks like. So how many workers do you need? That's going to depend on what your spec looks like. Did you put 20 terabyte per node? Did you put 10 terabyte? And also what the workload types are that you're running. Are you running high performance nodes, which have less storage, more CPU? Are you running archival storage, which may have up to 6 or even 6 to 8 terabyte disks in order to simply be stored as an archive and simply for Hive-based queries? It's all going to depend on that. And finally, once you have all that, you can start to look at your worker, your total cluster size. Apologies. Now, this is not a hard and fast rule, but this is generally what we see, how many master nodes you might need. So in early talking to your customers, this can give you an idea of how many you need. I would never recommend less than 3. Personally, I always go with 4 master nodes if you're counting in the management and edge nodes. And finally, within this architecture section, we can talk about the component layout and placement. What you see here in the larger gray boxes are various nodes. So at the top we have 4 master nodes, we have 6 workers at the bottom, and then we have 2 utility or edge or gateway or management nodes. They take many names. What you see by this is that every service has multiple components. HDFS, for example, has the name node, and if we're setting up a highly available environment, we'll have a second name node, a standby name node. And then at the bottom you see other worker nodes, and they have for HDFS they have the data node service, for Yarn they have the node manager service, and so on. And how we place these is one of the harder discussions when you're building a Hadoop cluster. Now for worker nodes it's pretty straightforward, and actually for utility nodes it's also pretty straightforward. It's on masters where we face a little challenge. And this is one example that works quite well. We have a much larger deck that covers many more of these, so again, contact us about going to a deeper discussion on these topics. Another thing I like to highlight is if you are running a cluster already or in the future and you see the term secondary name node anywhere, then you do not have HA. Within the community, it's been acknowledged that the term secondary name node is not the best name. That node does not provide failover or redundancy. The secondary name node is really a helper for the primary name node, simply so the primary name node doesn't get behind on certain tasks. You should make sure you enable HA, which you can do from Ambari with just a few clicks, and that will set up an HA name node. You should do the same for Yarn, so that will set up an HA resource manager. Now this is a small cluster. It's got basic HA of some of the services. It has HBase, it has Hive, and even has Nox on the edge. And you'll see there's 2 Noxes that are probably behind a load balancer. As the cluster grows out, we're probably in this case looking at a several hundred node cluster because we have over 10 masters. And you'll notice that some services have a dedicated host. If we're dealing with a cluster that large, HDFS is going to be really busy and probably have a lot of files. So we want to dedicate as much resources as we can to the name nodes, so they're on their own node. Ambari, there's multiple Ambaris with relational database that someone set up in an HA environment, and so on. And in some cases, they may have HBase only on select nodes that are more tuned for performance. Again, we have a larger selection of these examples, and it's something we can work with you on depending on the workload of the customer. One last visual. This is something we worked on during a security workshop for a customer where we're looking at the placement of different services. These are the types of things you'll get into and need to determine. Where are different components placed? Are they in the same VLAN or same network as the cluster? Are they sitting in a DMZ on the edge? Also, where's your test cluster? Where's your production cluster? Where's your DR cluster? And yes, you do need a test or dev cluster. Sometimes they're combined, so you might just have two environments, but you're always going to want a test and dev environment. That can be hosted on completely different hardware. It might be even on a cloud, but do make sure that the service configuration is the same. If you're running a secure cluster environment with Kerberos, then you definitely want your test cluster to be the same, because your code will be a lot different when it's configured to run with Kerberos and without. You also want to collect all the things that you're going to integrate with, such as the LDAP servers, the Active Directory, also all the databases that back Hadoop. Remember that Ambari, Hive, Ranger, Oozie, and other components depend on existing databases, such as MySQL, Oracle, and so on. You're going to want to outsource that management of those servers, the high availability of those servers, and the backup of those servers to your existing database teams. And people ask which is the best database to choose. Well, it's the one that you can manage best. So stick with what your people know and what you have a good vendor relationship for. Finally, we can't forget about integration and any infrastructure services. So from the integration side, it could be all of the different ways you want to get data in that you need to plan in advance, figure out the security, figure out the network placement. But also, from day one, you're probably going to want a secure cluster, and you're likely not going to want to manage users yourself. So you're going to want to connect to your existing Active Directory or LDAP or Kerberos environments. Further, just for deployment, you're going to want to have NTP services, because every node in a Hadoop cluster needs to have very exact time together. Kerberos is the same. And your OS packages, when you deploy a cluster, it's either pulling RPMs or Debian repository files, and those servers are typically HTTP servers. And if you're rolling out 100 nodes at once, you need to make sure those servers are built right. Also, when you're automating and deploying the OS, you're going to want to make sure you build the operating system so it's registered right, such as with the Red Hat channel or other mirrors you use. Now that leads us to Apache Ambari, which really sits at the center of most of the operations and management of Hadoop. I'm sure you're familiar with it, but just to note, it is the platform we use for operating Hadoop, and it can manage much more than Hadoop. Also, it's what's been adopted by the community through the Open Data Platform, IBM Big Insights, Pivotal, Hadoop, and others now adopting it. And some people use it to deploy other systems totally unrelated from Hadoop. With it, you're looking at managing the cluster, including the install, the deployment, and ongoing management, a configuration management, so you don't have to manage XML files yourself across every node you have. The extensibility with Ambari views and Ambari stacks, so that you can add your own services or your own dashboards to Ambari. The monitoring system that's built into it and integratable through SNMP and various APIs. And finally, the service management, so you don't have to go and manually start services across all nodes, and it handles all the various dependencies for you. This is just a highlight from one of our partners of the level of extensibility you can go into. This is Cave from KPMG. It's their analytics platform that they've built around the Hortonworks data platform. What they've done is they've extended the HTTP Ambari stack definition for Ambari and written a blueprint to roll it out. What you see in the background there on the left is actually definitions of something we call Ambari blueprints, where they're defining what every service should have. And what you'll start to see here, there on the left and then on the right, is with Ambari, they're deploying and integrating a whole bunch of services with Hadoop, such as Jenkins, Puppet Labs, Archiva, TWiki, various analytics tools throughout the platform. This is a great example of how you can extend the platform. So when you're working with the customer, if they have anything that's always deployed with Hadoop, maybe you can write an Ambari stack definition for that, or maybe one already exists to extend platform. Or if you have any vendors who are always deploying with Hadoop, you should encourage them to build it so it's deployed and managed from Ambari to make your overall management a lot easier. And you can find more contributions to the community, again, at community.hortonworks.com. There's a section called the Code Hub where you can contribute your own projects, or you can find projects from others. So let's get into the first thing you're going to do after you've really planned and spec'd out the cluster, and that's the install and the deploy. So something that was used in the community for many years, in the cloud community for many years, was the term cattle, not pets. Now this referred largely to the practice in some large manufacturer farming where if a cattle got sick, they got rid of it. Now, I don't agree with that practice personally, but that's how it was. But many of us treat our servers as pets and always have. I personally have always named my servers with comic book characters. I started with Calvin and Hobbes. But in the world of cloud, and especially in the world of Hadoop, when you're looking at your worker nodes, you don't want to treat them with special names. They should be data node 1, data node 2, data node 3, and so on, and that's it. If a data node fails, you just wipe the thing out, format it, reinstall another one. If the hardware fails on it, take it out the rack, go and fix it. Don't worry about it. Don't really be in a rush unless you have a small cluster, and then add back in. And when you're adding nodes, you're likely going to start adding them in more than one at a time. Once you get past 20 or 30, you're going to be adding them in large chunks. I know of one customer who adds 10 new servers, 10 new nodes a week. So they have to automate everything. Now this iceberg you see relates to Ambari. You want to use Ambari for most everything you can, and you want to use your standard configuration management on top of it. So Ambari sits below and just takes care of everything relating to Hadoop, and your standard configuration management sits on top and takes care of the rest. Now it's on you to choose what standard configuration management tool you want to use. Use what you know. If you don't have something, use what's best in breed, but you'll need to use something at that level, at the infrastructure and the operating system level. Now, for deploying Hadoop, there's really only a few steps at a high level to think about. First, you need to get the infrastructure in place, whether that be physical or cloud. Once the infrastructure is in place, you want to prepare those hosts, such as getting the OS up and running, and any requirements that are found in our documentation relating to installing, configuring Ambari, and installing the cluster. Then you'll go and install and configure Ambari, again, on all the hosts, Ambari server on 1 or 2, and then every other host will get the Ambari agent. I recommend doing this directly and then registering the Ambari agents with that host. There is another option to let the Ambari server install the agents for you, but it's not preferred for various reasons. You can ask in the community if you want to know what those are. Then you'll cover any security considerations, such as switching Ambari to HTTPS and other options I'll mention in a bit. And finally, you want to deploy the cluster using Ambari. Now you can do that either with the cluster wizard. It's a simple click-through wizard in Ambari. Or you can use blueprints, which defines what you would do in the wizard. It's a JSON description of what a cluster looks like, so you can do in a repeated way. You might also use this if you want to have a similar configuration for your development and your production or DR clusters. And yes, you can export a blueprint from an existing cluster. It has the whole definition of that existing cluster, modify it slightly to fit your test cluster, and then deploy with that. Now the automation options I mentioned before, they could be many. The open source ones you hear about the most today are Chef, Puppet, and Ansible. Though I know a lot of you are like me and you're probably still using JBoss, just a bunch of scripts. So use what you know, use what you're going to be able to support, or use what the customer knows. Some options that you can build on are my repository Ambari Bootstrap, which is a very simple shell script. I don't recommend it in production, but it's a good way to look at what you need to automate, the very basics. That repository also has some other tools, such as a deployment script that will actually write a blueprint for you. It will look at your hardware that you have in place, how Ambari is installed. It will write a blueprint for you. And with that, you can take that blueprint it wrote and then tune that to your needs, but be guaranteed that it's a functioning blueprint. Another that I follow is Rackspace's Ansible Hadoop. I follow it because they use it for deploying their own clusters in both their cloud and their dedicated. So this has been tested on hundreds of clusters. Therefore, it works. It wasn't a side project like many other projects for automating Hadoop where it was used once or twice. This is used in production by a company that knows operations. And there are many, many more. Hit GitHub, do a search, and you'll find many more if you want something to copy from. Or if you want, you can skip it completely. We have the Hortonworks cloud offering called CloudBreak, which is a cloud deployment tool which you simply provide credentials what you want the blueprint to be, the type of nodes you want, and it will go and deploy HTTP for you on various cloud providers, including Microsoft Azure, Amazon, Google, and OpenStack. Further, on Microsoft Azure, you can use their platform offering HD Insight, or they have a marketplace option for an automated HTTP deployment, which will get HTTP up and running on Azure nodes. Also, your hardware vendors, various hardware vendors will have some sort of integration, Cisco UCS, VMware's options, and on Google they have a script called BDUtil, which was updated to support the Hortonworks data platform. And finally, there are various managed hosting providers such as Rackspace who offer fully managed Hadoop, where they do everything for you from the install, from the ground up, and they have a cloud offering similar to HD Insight where they roll out a limited version of Hadoop, but it covers most everything in the Hortonworks data platform, but they make it turnkey for you so you can click and add nodes easily, click to deploy the cluster quite easily. Now, a little note that most people forget, but the sign of a good programmer is having lots of good tests for their project. A sign of a good operator is good baselining and continual benchmarking to the point that the baselining and benchmarking becomes their monitoring. The moment you complete installing your cluster, you will want to do some standard benchmarks. The most common is DFS-IO, the test that HFS is working and is performing well. And now I say the moment you install, I mean immediately after. Now typically you'll want to run any sort of test 3 times just to triangulate it. And then when you make a change, such as an upgrade, or adding a new node, or maintenance, replacing a disks, or adding new services, whatever it may be, you'll want to run this. Personally, I like to just continue to run it at least once a day as part of a scheduled run, or you could just have it running nonstop to account for any changes in your infrastructure. We go through this in more detail in a full-day workshop where we install a cluster from the ground up. We run this, we upgrade the cluster, we run again, and we see the differences in the improvement in performance as we add nodes. Now, that should only account for a small portion of your benchmarks. The rest of the benchmarks to say if a cluster is performing well are truly your own. So you'll need to define some sample workloads that are related to or exactly the same as the workloads that your organization is going to run. So if your first pilot's on Hive, then you're going to want to get some sample queries that you're going to use, or similar to what you're going to use, along with some sample data, and let that run just as you would with good programming practice and test suites. And I recommend recording that into something so you can do trends, likely right back into Hadoop. You might load that directly into Solr and use a dashboard in front of it, or HBase and use a dashboard in front of it to see improvements, see trends, see regressions. Let's briefly talk about monitoring and metrics. As you know, we have the Ambari metric system built in to Ambari, and it provides both monitoring, if you enable it, and metrics of what's happening in your cluster. You can integrate with this with SNMP, email, and even query it via the API. But we're not here to necessarily replace your own monitoring system. If you have a monitoring system you trust, or your customer trusts, you should keep using it. But do look to Ambari for what we believe are the best practices of monitoring and metrics. Or look to integrate through SNMP or other options. Also, Ambari Metrics looks at the service as a whole. But if you deploy a new Storm application or a new HBase schema, then the applications, those applications likely need further monitoring. So you're going to want to add additional monitors specific to those databases or specific to those applications, or with working with Kafka, specific to those consumers and producers. You want to add that monitoring, those metrics for them specifically. Now, to extend monitoring further, Hortonworks now has an offering called SmartSense. And so what SmartSense is our own Hadoop cluster internally, in which, with customers' consent, we collect certain information which allows us to offer suggestions about how they can better tune or stabilize their cluster. Before SmartSense, if a customer is working with Hortonworks support, what they had to do was manually collect files or use a script we send them to collect various files, and they either have to upload them to Salesforce for support, or if it was a larger file, into a system called Exavolt, and then the support engineer would get it, and it'd likely be a different format every time. But we looked to change that. So we created SmartSense, and now we built it into Ambari as a service that you can enable. And once you have, or your customer has, Hortonworks support access, they can simply use Ambari and the SmartSense plugin to create a bundle. That packages up the various files they need with lots of options for security and redacting certain information. And then they can either just send that to support, attach it to Salesforce, or upload it. With that, the Hortonworks support engineer has a consistent set of files that they get each time from the customer and from all customers. Therefore, we can provide better support. The other option is integrating with SmartSense, the analytics platform, and from Ambari itself, you can send the bundle straight into that system. And then from the support control panel, you can access the various recommendations that SmartSense gives, which I'll show in just a moment. This is an example of that. There's an Ambari service and view for SmartSense. With the customer doing it, we don't proactively touch the cluster. We don't have access to the cluster. With the customer doing it, they go and choose the various options they want, any redactions, removal of certain data, and so on. And then they upload that bundle into the cluster directly from Ambari. So what we have now is we have a much more streamlined way to get our data to the support engineers in a consistent way, and we have an analytics platform. If I go look at that now, this is looking at support.hortonworks.com, which you should have for any of your customers who have a support subscription, as they should have from day one. And then I can click on SmartSense. Bear with me. And then I can see, make it a little bigger, I can see I have a few clusters here. These are just samples that we keep there for people to browse through. And with that, I can see that on this particular cluster, there's 2 critical warnings, 11 high, and so on. I can see the amount of storage used. And we're continuing to advance this. We rolled this out last year, late last year, so it's still a very, very evolving system. And once I click on a cluster, I can go see a lot of recommendations about things to tune, things to change, or actually warnings about things that could cause some major issues. Now these are just a few, and I'll distribute the slides so you can read this. These are just a few of the examples of things that we solved with SmartSense. Now this happened before we even went public with it. This was in a small test with just a few customers. Things we discovered immediately that we would have probably only discovered after they happened and we started investigating them, but we caught them before anything happened. Let's briefly talk about security. The intent today is not to go over how to secure a cluster. I personally spend one full day for pre-sales and solutions architects talking through security and how to secure a cluster. And then we have a multi-day security training course. It's either going to be 3 or 4 days that we're releasing this quarter. So look to follow up on that for anybody that's actively securing a cluster, any operators that you have. Now first you're going to look at Ambari. Ambari is really separate from Hadoop. Once you install Ambari, it's all on its own. It can do several different things. It could deploy other things than the Hortonworks data platform, but there's a multitude of things that you could deploy with it. A few you're probably going to want to do every time, such as encrypting the database, switching it to HTTPS, possibly using Kerberos in a Kerberos environment, and so on. These are all in the docs, so just go check there. I just want to remind you of those. But we're looking at Hadoop. There's several things we need to look into. Now, the most notably, the one I want you to take away from this video, the one you cannot forget, the one you must make sure you do and make sure your customers do, is relating to authentication. And that's because Hadoop has no authentication by default. This is not a Hortonworks thing. This is an Apache Hadoop thing. If you go to hadoop.apache.org, you will see this quote, and this applies to every Hadoop distribution there is, that by default, Hadoop runs in non-secure mode in which no actual authentication is required. So Kerberos is a must. The original developers of Hadoop saw fit that we should use what already exists, what's well known, and what's well secured for large multi-server environments, and that is Kerberos. Why make yet another authentication scheme when we have Kerberos to integrate with? Now for those of you that understand Unix formatting, What you see here is I have a user logged in. We've called him bad user. And then they've listed what's in the temp directory. And so we see, coming from right to left, is we have the directory temp secure, we have the date and timestamp, we have the group that's assigned to each HDFS, we have the user HDFS, and those settings on the left there tell me that for this directory, only the HDFS user has access. So as the bad user in the next few lines, I went to list what's in that directory, and what I got back was what I expected. Access denied, permission denied. That's good, right? Well, very easily, just by specifying a variable, I can override and bypass that. That's because, if you recall, Hadoop is its own world. It's sort of its own operating system sitting on top of Linux. You're just logged into the Linux console. You're not within the Hadoop cluster. So when you run a Hadoop command, it's just inheriting the username you used. So if I'm logged in as bad user, it just says, well, I think my user's bad user, but nothing's authenticated to the cluster. So I can simply override this by putting Hadoop username. You could do this in Java code if you're connecting to Hadoop. You could do this from Web HDFS, Hive, and other places, and you could override and bypass this. And again, that's because Hadoop does not have authentication on its own. It needs Kerberos to be enabled. So all of your clusters should be Kerberized. Now, Kerberos scares some people because it can be complex and confusing or fairly academic. To make this easier, within a bar, we've created the Kerberos wizard, which we continually make easier and easier. Over the last 2 quarters, I've run a multitude of security workshops with our partners, and in one day, I've had anywhere from 30 to 50 architects Kerberize a cluster, typically in just a few minutes. So if you have all the right details from your Active Directory or your KDC operators, and you work with them, then getting Kerberos enabled is actually quite easy. Now we go into more detail of what all you need to get from them, even the business decisions about whether you use Active Directory or you use your own local KDC, and a multitude of other issues. How do you talk to a security officer, and so on. We get into that in larger security workshops. So ping us at partnerdesk@hortonworks.com. Sorry for repeating it. If you're interested in that level of detail. Again, what we're talking through today is just an introduction of what you need to be aware of. Now, after we got the authentication, there's more authentication. At the perimeter, you have something called Apache Knox. This acts as a sort of reverse gateway so that users are never within the cluster. Now, many of you are likely people that manage databases in the past or web servers. Now, if you have a database server where someone needs to run a query against, would you ever allow them to SSH in to the actual database service to run the query? No. They would always be connecting from another host. They'd have certain permissions associated with that host, such as that web server or their own desktop if they're hitting a data warehouse. But it seems that a lot of Hadoop operators like to let the users log right into the Hadoop nodes. Don't. You shouldn't do it. Just as you wouldn't let users log in to your database server. That's one of the reasons that Apache Knox exists. It sits at the edge. It can authenticate users, thus making access to them easier for users that won't have Kerberos access, such as through an external web panel, or let's say they're connecting to Hive via Excel or some other platform. It means they never are inside the cluster. It also means that you have a single access point for auditing and logging. You have a single place they connect. If you move the servers around your cluster, it doesn't matter because they're going to have a single name for the Knox server. You put a load balancer in front of it, and it's even better because you can scale that up and down. And one benefit I love, nothing related to security, is that it's an API gateway, which means first you can continually add new services yourself, and it's not very hard. So you have a third-party app or your own application, you can use Knox as that gateway. As we add new services to the platform, they'll be added to Knox. And the thing I am a fan of the most from an operations standpoint, and just a developer management standpoint, is everybody's using the same API. So everybody's developing the same. Instead of having random bits of code or clustered, scattered around servers, you have a single standard for how people communicate with your cluster. Now, after you've given access to the cluster, either through Knox or through an SSH edge node of some sort, then we need to authorize what people can access. So this would be your file permissions. This would be your grant and select statements in Hive and HBase as you would have with other databases. This could be your permissions for what queues jobs can be submitted to in Yarn, and so on. Apache Ranger integrates at the core of Hadoop, so applications don't know the difference. You just use your applications, and Ranger is there in place to work with them. But what Ranger gives you is a single administration panel for authorization across the stack. So instead of managing HDFS separately, Hive separately, and all these things separately, you have one place. This is actually puts Hadoop ahead in the ease of managing compared to a web stack where you had to manage the OS authorization, the database authorization, and all the web service authorizations, all these things separately. Ranger lets you do it all from one place. And it's a pluggable architecture that will continue to extend. You can extend yourself. And now, we're coming up in future version of HTTP, which we'll go into tech preview for fairly soon. We'll have integration with Atlas, which will go further to give us dynamic condition-based policies. So not only on the user and group, but on various tags and attributes that fit into different governance models, such as is data PCI related, therefore it should have different rules on it. With that, you have a single audit platform. With Ranger in place, you have an audit of all the different systems. This is huge because previously you had to go to the Hive logs, HDFS logs, and so on to audit. You have a single audit log for all of them. Now, in a recent release in HTTP 2.3, we released Ranger supporting Solr as a backend. Previously, it was a simple database. Didn't scale that great, and it was hard to report from. Now you have Solr, so you can get real-time dashboards. This is just one example that a colleague of mine built out, showing a real-time Solr dashboard that's updating every 3 seconds, I believe, with what's happening in the cluster. You can see the top users. You can see, are they accessing HDFS or Hive, and you can customize this to your heart's content from any Solr type dashboard. In this case, we're using a banana dashboard. Now, after you've gone through who can access the data, are they who they say they are with authentication, data protection comes up. So what's often asked these days is encryption at rest. It's typically a requirement not from the operators or any users, but from a compliance officer. And the options there are HDFS transparent data encryption, which is built into Apache Hadoop for quite some time, and we now consider very stable. We released it into GA earlier in 2015. And then we added to that the Ranger KMS for making managing that much easier, managing the key stores, and making the key store system more scalable. Or you can even integrate with existing KMS, key management systems. Other options are partner and enterprise-wide solutions. Many of you already have solutions that you use for encryption and should continue to use them as long as they work with Hadoop. Or if you're working with a customer and they have said, look, we want to use the same REST encryption suite that we use across our environment, then opt to use that instead of the TD, or opt to at least integrate it to KMS so you can use the same keys. And then there's encryption at motion, wire encryption. Now this is across the platform. There's a multitude of places to encrypt at the edges, within the cluster. There's a lot more of this in our docs, and we cover it more in our longer training or security workshops, and in the longer security training course that's going to be released for operators in the coming months. So that gives us administration of all these things: authentication, authorization, audit, and our data protection, our encryption. And once you've got your security in place, you've got your cluster running, you've benchmarked it, you're going to want to add high availability. Now, I'm not going to go into details of how we configure that, but just to say you want to configure HA for most everything. You especially want to configure it for services that are offering up something your users are using, such as the name node for HDFS, the resource manager for Yarn, the HBase masters, the Hive server, any of the other data services. You can also go and make Ranger HA, Oozie, and other services. Now, behind every service, not every service, behind most services, such as Embari, Hive, Oozie, Ranger, there is a relational database, such as a MySQL, an Oracle, Postgres, or in some cases a Microsoft SQL. These are all options. Again, you need to make them HA if you want the whole environment to be HA, because if that database goes down, then the parent service will be down no matter how many nodes you have for it. And again, as I said earlier, you likely want to outsource that to an existing team in your organization and use the technology they know best. Let them back it up, let them make it HA, but do put it in close relation or within the same physical environment as the Hadoop cluster. Now, enabling HA for most services is as easy as a few clicks from Ambari. So you can find all that in the docs. If you're interested in going through it yourself and learning more, then look at our operations training course or talk to us about our one-day operations workshop for solutions architects. Let's look at upgrading the cluster. So as time goes by, you're going to want to upgrade it. In the past, this was very painful. And each new release and my release of HTTP, we've been adding something we call rolling upgrades. And each new release, it gets more and more efficient to make your life a lot easier when you're upgrading the cluster and reduce risks. The goal is to have a reliable, safe, efficient process. The ability to start, checkpoint, and even roll back at certain points within the upgrade process. Even upgrading specific service at a time so you can schedule throughout. We want to really limit the service disruption. If you're not HA, this won't work very well, so you need to have HA to have a rolling upgrade at all. But we're able to schedule and reduce the interruptions that happen. If we're upgrading all the data nodes, we can upgrade a few at a time so that jobs can keep running, just as an example. Now, if you're in a smaller cluster, you'll probably see some performance degradation, so you're going to want to control the time. You want to manage any SLAs with your customer. There's much more detail on this. We actually do this as a hands-on within the training courses and when our one-day workshop. So talk to us more about it and see the docs on more of it. We'll want you to let you know it's there and let you know that it's continuing to get stronger and stronger and easier. Now, of course, we can't forget backup and disaster recovery. In general, when you're looking at backup of your master nodes and your database services, you would treat them like you would master nodes in any environment. Back it all up, OS, everything. If you're running it virtualized, then do it in such a way that you can fail it over to a whole other node and possibly even put some of the disks on SAN, depending on how you have it configured. For your master nodes, the most important thing is your name node data. Within your whole cluster, the most important thing, along with your HDFS data, is your name node metadata. Now, unless you choose to copy it somewhere else, the only place this data exists is on your name node and your standby name node, on your two name nodes. If you lose that data, then you've basically lost everything, because your data nodes only have the actual data. They don't have the pointers of where things are. So you need the name node data or the journal and other components of that to understand what is actually in your file system. So protect it more than you protect anything you have. Back it up. Some people will replicate it onto an NFS. Whatever. Just make sure you have that nice and safe. And of course, as I mentioned, in the database services, you'll want to back up and you'll want to manage appropriately. When it comes to DR and business continuity, there are many options. I could spend half a day or more talking about those options. So you are going to want a DR cluster or a HDFS compatible file system, such as an Isilon, an Amazon S3, Azure Blob Storage, OpenStack Swift, or Google Storage that you copy onto. The discussion really gets into, do you want your DR cluster to be fully DR so you have continuous availability, in which case you're going to want to build another large cluster. You may even distribute workloads across them so you don't just have one cluster running doing nothing. So you might have analytic services on one cluster, and you may have your archival and general queries done on the other and be replicating between them. You may go further. If you don't want to replicate all of your data, you may just replicate the base data and then have the ability to recreate any views, any materialized information on both sides, so you're not replicating that data. There's many options of ways to do this. We talk about it more in other areas. It's something you need to discuss with your customer and discuss with us as you get into the rollout of your clusters. Even before you are rolling out, really, in the planning stages, you need to discuss how you're going to handle that. Now, this is the most important little tip people overlook, and that is PEPCAC errors. Some of you will know what this means. It means the problem exists between the keyboard and the chair, or simply users' errors. So there's something in HDFS, Hive, and HBase that each have the idea of snapshots. Similar to file system snapshots for using Windows, the old shadow snapshots that are still there today, that you can run at any interval, hourly, or however often you want, and then the users themselves can go restore files they accidentally changed or deleted. You also have a trash, just like you have in your desktop, that's at .trash in any directory, so that if someone accidentally deletes something, they get it back. So make sure you schedule snapshots. You can delegate that down to the project administrators if you want, and ensure HDFS trash is enabled. It should be enabled by default, but make sure no one disables it. And the last little thing we're going to cover, I believe, is multi-tenancy. So Hadoop is not meant, well, you can, it's not meant to be used for just one job. The whole point of Hortonworks creating the idea of Yarn, even before our founding, was so that you could use a cluster for more than just one job and one use case. So multi-tenancy inside of one large shared cluster is the idea that you have multiple business units using the cluster, and within each business unit you have multiple applications, aka jobs, running. So if you do it from the user story perspective, you would say, as head of the web production department, I must ensure my applications get appropriate resources and meet their SLAs. Meanwhile, you might have another department that wants the same, but what they need, it can have slower response times. But the front-end website, that can't go down. That needs a really high SLA. Or potentially, that department's paying for 60% of the cluster, so they get 60% of the cluster, and you allocate that to them. Now for this, we need a few things. First, we need shared compute and memory capacity and scheduling. That's done by Yarn. We need shared storage capacity. That's primarily provided by HDFS, quotas within that, and similar things within Hive and other components that sit on top of HDFS. And finally, any of the security controls, either with the raw security settings or simply by using Ranger to manage all of your security. Now within Yarn, the key thing that makes all this happen is something called queues. What queues is they're an endless tree structure where you can define different groups and the access they have. When jobs are submitted into Hadoop, into Yarn, they're submitted to a queue, either the default queue for that user or group, or the queue that's defined. So this example, we have 10% of our clusters to support, 60% to engineering, and 30% to marketing. And then under each, they've built out their own departments. That would likely be delegated to the Hadoop administrator for that department or project. And then they have all these little groups underneath. So underneath marketing, 70% of the capacity that marketing gets goes to sales, and 30% goes to advertising. These can be changed fairly quickly on the fly as well if you change by time of day. They can also be set to be burstable, so you're always getting full use of your cluster. For example, support and marketing might not need anything to run at night. So engineering may be given a burst up to 95% of the cluster, so at night they can run some complex jobs throughout the night. When morning comes and support and marketing want resources, any of the work being done by engineering is slowly brought back to their 60% that they're allocated. There's also something called node labels, which is beyond our topic today, which allows Yarn to specify specific nodes that are going to get certain jobs. Maybe you have tuned certain nodes to high CPU for Spark or other use cases, or simply segregation in some context. You also want to look at securing this. I see a lot of people make Yarn queues, but then they don't set any ACLs from Yarn or from Ranger for them, and even though people are defaulted to engineering, they could really just throw a job anywhere. So don't do that. And once you have everything working, you're going to want to take away almost all the percentage that the root queue gets. You may just want to give it 5% so the jobs just don't fail, and if you want to really be harsh, then you would just take away all the queue access to the root queue. Now after we've dealt with Yarn, we'll want to look at storage and security. This we've largely spoken to. The main thing to look at are the name quotas and the space quotas within HDFS, and read up on how they work on our documentation and on the at hadoop.apache.org. They work differently than quotas in other systems. They're not necessarily tied to the individual, they're tied to the path within the system and the number of files within the system. There's two settings there. Further, we then have the security controls, either from the raw Hadoop security offerings or from Ranger and coming in the future with the integration with Atlas. And final thought relating to multi-tenancy is something we call tenant onboarding. Now, this is a larger topic. It's going to vary a lot by the project and the organization. But what this is talking about is what you yourself experience when you start a new company. You just started, so they have to get you a laptop. They have to give you an email. They have to get your password set. They have to give you access to your CRM, your mail, and lots of different systems. They have to set up a home directory, all those things. Same in Hadoop. We've got your user directory in HDFS. In our Active Directory in LDAP, we have you put into the Hadoop group so you can access the cluster and run certain jobs or maybe log into Ambari. We have the Yarn queues you need to access, the Hive tables and databases you need to access, or any new Hive tables for you. If we're looking at it from a project or departmental level, it might be a new queue for that group. It might be a new group directory, new members, scheduling of snapshots for the past they have, and so on and so forth. This is a much larger topic, but it's one you need to consider. If you just spin up a cluster and then new users start to come on board, you'll immediately start to have to build this process anyway, so you might as well plan for it. Most organizations will end up having a wiki of some sort internally where they have what the process is for onboarding new users or new groups or tenants, as we call it, to the cluster. And we can talk about this more with you in our experience from other customers. Some have gone so far as built dashboards so they can just click through to create various aspects of the tenant onboarding process. With that, I want to say thanks, and I'll have some next steps. I hope I haven't talked too fast. I plan to go a little bit longer than this, but there's a lot more information out there. As I've said, we have many workshops we can do or things turnkey for you as a partner. Just contact us and we can work out what's the best fit for you. For people that are actually doing the operations, so your professional services team, your actual operators that are sitting on the site with the customer and building up the clusters, they're going to want to look to training.hortonworks.com for our larger courseworks and then to become a certified engineer. If you're a solutions architect, pre-sales, or even a salesperson that's very technical, we have a variety of things. In Europe, I've been running one-day courses on an ad hoc basis for our partners and customers. It's something we can definitely do for partners around the world. Just contact us and we'll see what fits right for you. So with that, do check out our other partner architecture enablements we're putting up. And let us know what else you want. Tell us directly at partnerdesk@hortonworks.com or just ask on community.hortonworks.com. As I said, go to the training if it's fitted for you. Contact us for other enablements and workshops. And as always, go to hortonworks.com/partners/learn for our webinars, technical webinars, partners/resources for other resources, and the partner portal that you should have access to. Finally, deploy the clusters for your customers. When with us, when with you, then start to use SmartSense immediately. It will add a huge value to those customers and to your learning of how to use Hadoop and how to scale it, make it stable. And finally, let's grow the clusters together and with your customers. This is just to remind you of the training that's available at training.hortonworks.com. This is just one, the operations course. There's also a security course coming this quarter. We're just testing it as we speak. With that, thanks for listening. Contact us, join the community, let us know how we can help, how we can work with you. Bye.